We continue to look at our exercise on change of variables in partial differentiation. This question here, and by the way, I'm not in the best of health right now, so my voice isn't so clear. But here, w is equal to 2x to the 4th minus 3x squared y cubed. X and y are themselves functions. They're functions of t. X is 5 plus 2t and y is 5 minus 2t. We're supposed to find delta w by delta t. Okay? Notice that if we were asked to find delta w by delta x, we wouldn't have any problem. We have x here. Or find delta w by delta y. Wouldn't have any much of a problem, but here it's more complicated and we have more problem because we're supposed to find delta w by delta t. So let's see how we're going to deal with it. Now, the formula, the main formula, you should remember. Delta, a small change in w is equal to the partial derivative of w with respect to x. That means the rate at which w changes as x changes times a small change in x plus the rate at which w changes as y changes times a small change in y. Now what we want eventually is the rate at which w changes as t changes. So let's say we have a small change in w divided by a small change in t. Small change in t, we have to divide here by a small change in t and here by a small change in t as well. Alright, what we have now is a case where when we have the limit of a change in t tend to 0, then what we have is the rate at which w changes as t changes is equal to rate at which w changes as x changes times the rate at which x changes as t changes. Multiply, alright? Plus the rate at which w changes as y changes times the rate at which y changes as t changes. Alright, notice also, if you consider delta w over delta t, we could cancel out the delta x's and get delta w over delta t here, you see that? And we could cancel out the change in the delta y's and get delta w over delta t here as well. Alright? But anyway, let's find each derivative. We need to find delta w by delta t, or by delta x. Let's find by delta x, which is this one, right? Delta w by delta x going to be 2 4s 8 x to the 3, so it's 8 x to the power of 3 minus 3 2 6 is going to be 6x y cubed. Alright, so you see that. Now, this one now, delta x by delta t, what is it? We have x equal 5 plus 2t, so delta x by delta t would be 2. Alright, so you see that. Suppose now we want to find delta w by delta y. What do we get? Well, this is going to be negative 3 by 3, which is 9, negative 9x squared y squared. Alright? Negative 9x squared y squared. And delta y by delta t is equal to Well, you can see here is negative 2. So we put it all together now. Delta W by delta T equal. So remember, these here are the 4 partial derivative that we were looking for, right? So delta W by delta T. Not T. X, I should say. Delta W by delta X. Got that? Oh, wait, by T, right. I was right the first time. Is delta W by delta T, right. My. Let me rewrite that. Delta W by delta T is equal to, alright, it's delta W by delta X, as we have here. And you see it here. Going to be 8x cubed minus 6xy cubed multiplied by, it's multiplied by delta x by delta t, which is this, times 2, plus, and after that delta w by delta y, k is this, negative 9x squared y squared, times delta y by delta t, which is negative 2. So delta w by delta t is equal to 16x cubed minus 2 is 12 xy cubed was going to be plus, because negative 9 by negative 2 is got positive 18 x squared y squared. Good. So in that case, that is delta w by delta t.